What's up, Mr. Rice? Today we'll be learning about nuclear fusion, section 2 of what is the final chapter in our textbook, chapter 30. Our sun, along with 90% of the stars in the universe, are created and maintained through natural nuclear fusion. What happens in this process involves the proton-proton cycle. Basically, what happens is that atoms known as protium, the most stable form of hydrogen, collide and form deuterium ions and a bit of energy. It's important to know the isotopes of hydrogen, which include protium, deuterium, and tritium. Protium has only one proton and one electron. Deuterium is the same as protium, except it has one neutron to add to the mix. And tritium is the same as deuterium, except it has another neutron, giving a total of 2 neutrons. Going back to the cycle, these deuterium atoms then collide with more protium atoms and form helium-3 atoms, and release some energy as well. These helium-3 atoms finally collide with another helium-3 atom and form helium-4. They also release 2 extra helium protons and some energy. Helium-3 and helium-4 are the only known stable forms of helium. Helium-3 has a nucleus composed of 2 protons and 1 neutron, while helium-4, the most common isotope of helium, is composed of 2 protons and 2 neutrons. All these thermonuclear fusion reactions occur simultaneously and spontaneously throughout the sun's core, with each one producing just a little bit of energy. However, take the 100 undecillion fusions per second that occur and you create a whole lot of energy, which gives us the sun. But a sun can't randomly just pop up when these atoms bond. The environment must meet certain conditions. First, the temperature must be high enough, about 10 million Kelvin, to allow the hydrogen isotopes to collide. Otherwise, their natural repulsion would just push them apart and prevent their fusion. Second, the atoms that fuse don't have to be hydrogen isotopes. In various other stars, any atoms can bond as long as they have a high enough density to ensure a high rate of collision. In our current society, scientists have been trying to harness the power of the sun to create an efficient, powerful source on Earth using fusion reactors.
The power of the sun in the palm of my hand.
In a moment, I'll be showing you a few clips from 2004's Spider-Man 2 that involves nuclear fusion as a power source. The process that occurs in fusion reactors is slightly different than what occurs on the sun. What happens is that the 2 atoms, deuterium and tritium, fuse together, producing helium-4. They also release an extra neutron and a little bit of energy. Each fusion releases about 17.6 mega electron volts, which is about this much joules. Mega electron volts are also known as MeV. Once again, even though there is not much energy produced in the fusion, the whole reaction still creates an enormous sum of energy. In this video I'm about to show, the fictional Dr. Octavius is a physicist who is trying to create a nuclear fusion reactor to power the city of New York. He fuses tritium atoms to start his proton-proton chain reaction.
Precious tritium is the fuel that makes this project go.
There's only 25 pounds of it on the whole planet.
I'd like to thank Harry Osborn and Oscorp Industries for providing it.
Happy to pay the bills, Otto.
Ladies and gentlemen,
Fasten your seatbelts.
Doctor, we have a successful fusion reaction.
This is a breakthrough beyond your father's dreams. Thank you.
We're producing 1,000 megawatt surplus.
The power of the sun in the palm of my hand.
experiment starts off well, but of course something bad has to happen.